In today's lesson, we're going to go over a concept in probability of combinations and permutations. So I want to first give you an overview and then we'll dig into the specifics. So big picture, before we get into the specifics, combinations and permutations are a way to select groups out of a set number. So I'm just going to do, we have a set number of 4 things, 4 objects. A combination, the order doesn't matter. So if I wanted, of these 4 objects, I want 3 of them. Okay, my different combinations would be, I could have 1, 2, 3. I could have 1, 2, 4. I could have 1, 3, 4. And then I could have 2, 3, 4. Those are all of the different groups of 3 numbers where order doesn't matter. A permutation, the order matters, which means 1, 2, 3 is different than 2, 1, 3 is different than 2, 3, 1, which is different than 3, 2, 1. I should have also had 1, 3, 2, and 3, 1, 2. Okay, and these would each have that same repetition. So combinations, there was just 4, but permutations, where this counts different than this, those are permutations. So a permutation is the arrangement of objects where order is important, where order matters. To find it, we're going to use something called a factorial. Okay, n factorial is going to be n times n minus 1 times n minus 2 2 times 1. So you're going to count all the way down. So if I wanted 7 factorial, that's actually going to be 7 times 6 times 5 times 4 times 3 times 2 times 1, which if you count that up gives us 5040. Okay, so we have 2 factorial formulas. So a formula for a permutation, n distinct objects is taken r at a time. So in my previous example, the n was 4. We had 4 numbers, and we wanted to pick 3 of them, and the order mattered. So it's going to be n factorial divided by n minus r factorial. Okay, this is the notation. Okay, and then if objects are repeated, we're going to use this formula, n factorial divided by the repetitions. All right, so this can be a little tricky, so we're going to just think through this, and then I'm going to show you actually how the calculator is going to be super helpful for us. Okay, 30 people sign up to audition for a talent show. Contestants are called at random to perform for the judges. What is the probability that Eli will be called first and Mia will be called second? All right, so the possible outcomes. Okay, we have 30 people and we are going to rearrange them in, all of them are going to be selected. So 30p30, okay? This is actually going to be a very, 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 very large number. So I'm going to leave it like this, and I'm going to show you how we'll use the calculator. So that's all of the outcomes. But let's say that Eli was picked first, and Mia was called second, and then that leaves all the other contestants, okay? So the ones that we are interested in are the ones where E is first, M is second, and then all of the different permutations here. Well, this, we have 28 left over. So the favorable outcomes is going to be 28p28. So this is going to rearrange all the different ways I could write that. So my probability is favorable, which is going to be 28p28 over possible, 30, our sample space. Again, these are really big numbers. And even though the formula has factorials, the calculator is actually a very handy tool for this. Okay. So in our calculator, there's 2 ways to do this. So I'm going to type in 28. Option 1 is to go to math over to probability. Over to probability, and there's NPR. So I'm going to do 28p28. And I'm going to show you, this is going to be a mega big number. That means we're this number times 10 to the 29th. So I'm actually going to use the fraction. And in the top, I'm going to do 28p28. So we can do math, probability, NPR 28. And then in the bottom, I want 30. The other way to get this p, if you have a TI-84, these F1, F2, F3 are shortcuts. So the first is fractions, then functions, then matrix, then y variables. In functions, we have factorial. We also have NCR and NPR. Okay, so I'm going to do that, and that's going to do all the math for me. Okay, and that's our probability. So this is, there is 1 out of 870 chance that that's the scenario. Mia goes first, or Eli goes first and Mia goes second. Okay. You have a textbook for each of the subjects: Spanish, English, chemistry, geometry, history, psychology. If you choose 4 of these at random to arrange on the shelf, what is the probability that the geometry textbook comes first and the chemistry book will be second? Okay, so again, I like drawing these out. So we're going to have geometry, followed by chemistry, followed by 2 more books. Okay, so my possible outcomes, I have 6 objects and I'm permutating 4 of them. So we have 6 total books. 2 of them will not make the shelf. So here, GC, that means that's my remaining. Okay, so if I take the 6 books and I'm taking geometry and chemistry are out of the rotation, that means I have 4 books left, but I'm only picking 2 of them. Okay, so my desirable or my favorable is going to be 4p2. Okay, we can go ahead and calculate those. Those will be significantly smaller. So just to show you, if we do 6p4, that gives us 360. And then 4p2 is 12. So we can do it like that. So my favorable is 12, my possible is 360. That reduces to 1 over 30. And if you're not sure, so I've got 12 divided by 360. You can use, if you do math, the very first option is to fraction. It'll turn it into a fraction for you. And then if we do this, that's 3.3%. Okay, so I want you guys to try the next one. So if an ID consists of 4 digits from 10 possible, from 0 to 9, so the possible outcomes are 10 and we're permutating 4, because 1, 2, 3, 4 is going to be different than 2, 1, 3, 4. Those would be different IDs. What's the probability that it's exactly 1, 2, 3, 4? Well, of those 5,040 possible outcomes, only one of them is going to be 1, 2, 3, 4. All right, next we have, what is the probability that a 7-digit phone number generated using 2325273 is this exact number? Okay. Well, this is the second formula where the top is n factorial. So that's going to be 7 factorial. I have 7 numbers, but some of them are repeated. So if I switch this 2 and this 2, it's still the same phone number. So we divide out any repetitions. So we have 1, 2, 3 2s. So I'm going to divide out 3 factorial. I have 2 3s. So I'm going to divide out 2 factorial. And then there's no other repeats. Okay. You might have noticed in both of the previous menus, if you do the math over to probability, we have factorial right there. Or if you do the shortcut menu, we have factorial there. So I'm going to do my fraction bar, which is really helpful in grouping. So I'm going to do 7, and then alpha F2 factorial, and then in the bottom, 3 factorial and 2 factorial. So there are 420 different outcomes, so the probability is 1 over 420. Right, you go ahead and try the next one. So it actually ends up being the same thing, because we've got 3 repeated 3 times, F repeated 2 times, and there's 7 total. So we have 420 possible outcomes, so one of those is our desirable. All right, a combination is an arrangement of objects where the order is not mattered. So the notation is NCR, and then the formula is n factorial over n minus r factorial r factorial. But we're just going to let the calculator do that work for us. All right, so Taryn has 15 soccer trophies, but she only has room to display 9 of them. So if she chooses them at random, what's the probability that each of her trophies come from the invitational from 1st through 9th grades will be chosen? Well, the possible outcomes, okay, is going to be 15C9, because we don't care if we did 1st grade, then 2nd grade, or 2nd grade, then 1st grade, as long as they're in the set. Okay, so this ends up being 5,005. Oh, I should show you on the calculator. Okay, so the same 2 ways, either, so we'll do 15, and then either math, probability, NCR 9, or you do 15, F2, and down there is C9. So there are 5,005 possible outcomes. Only one of those is desirable, specifically 1st through 9th. So my chances of getting 1st through 9th grade specifically is 1 out of 5,005. Callie has 20 choices for her triple scoop cone. If she chooses the flavors at random, what's the probability that the 3 flavors she chooses will be vanilla, chocolate, and strawberry? So we're saying as long as these 3 are there, then it's a favorable outcome. They could be, on the cone, it could be chocolate, vanilla, strawberry. We don't care about that part. Okay. So there are 20 to choose from, and we want to choose 3 of them. So if we do that in the calculator, that's 1140. So only one of those is going to be our desired thing. All right, you guys try the next 2. All right, so these are all just more combinations. If you got 9 dogs and we want to pick 4, it doesn't matter if we have Fluffy then Spike or Spike then Fluffy, we just want them in the group. So that's 9C4, which is 126, so the probability is 1 out of 126. 10 new restaurants, if we want half of them, is 252, so there's a 1 out of 252, it's those specific restaurants. And then 20 choose 10 gives us this one. Okay, so that is combinations and permutations. They can be challenging, deciding whether what you're being asked is a combination or permutation. But just think about, does order matter or does it not?